Yesterday our lesson was on the composition of functions. Composition is an operation. Today we learn about inverses. Inverses is an operation as well. In order to talk about inverses, we first need to talk about what it means to be one-to-one. This is something you're going to need to know for your test. A function is said to be one-to-one if every element of the domain corresponds with exactly one element of the range, and every element of the range corresponds with exactly one element of the domain. So, as long as you know the definition of a function, this shouldn't really be that big of a deal. I'll let you write that down. My broad shoulders again. You could just say, Mr. Gantz, your shoulders are too broad. Mr. Gantz, your biceps are too large. Can't see round. Mr. Gantz, your neck is too thick. Please, like anything like that would work. Mr. Gantz, you're far too tall and good looking. And okay. Mr. Gantz, your ear hair is too far. Like you could trim that a little bit. What? What? Say it. Say it, Rhiannon. Yeah, Rhiannon's gonna insult me.
Mr. Gentz's ego is far too big to learn about this subject.
It's like, not really. I mean, I thought you should go further than that. All right. Okay. Whatever. So yeah. All right. Here we go. So. True or false? Is that a function? True. It is a function, right? I should have said true or false. That is a function instead of asking a question. So that is a function. Why? Why do you say it's a function? Pass the vertical line test. So now let's examine: is it one-to-one? It's not one-to-one. Why? Okay. So we haven't talked about the horizontal line test yet. It says that if you have an output of 0, so I have a range value of 0. How many domain values correspond? We're supposed to have 1, but we have 3, so therefore it fails to be one-to-one. So in order for a function to be one-to-one, I must pass the horizontal line test. So some people say, well, okay, so what about that? Well, that's not even a function. So we didn't even get past the vertical line test, did we? Okay. So, maybe something like, that. Okay, that's one-to-one. Passes the horizontal and the vertical line test. If functions are one-to-one, they have an inverse that we can find without much of a problem at all. Okay? Function inverses is where we take the domain and we put it to the range. We take the range, we put it to the domain. In other words, we take an XY ordered pair and we turn it into a YX ordered pair. So, yes. Yeah, it is. We'll investigate, and I guess cool and beauty is in the eyes of the beholder. But since you have a broad, open perspective, and you'll be objective, I think you'll find it fascinating. So, the function, let's say you have a function of 2, 6. That's a function. It's not very interesting. It's just a point. What would the function inverse be? Be 6, 2. If I asked you what is f of 2, what would you tell me? It's 6. If I ask you f inverse of 6, what would you tell me? You'd tell me 2. That means given an output of 6, what was the input? That's what that means. Given an output of 6, what was the input? Those are the questions that we ask. So suppose you have y is equal to 3x minus 6. Then in order to find the inverse, we simply switch the x and the y values. And we get x is equal to 3y minus 6. And we will then solve for y. How would you solve for y? Add the 6 and divide by 3. So x plus 6 over 3 is equal to y. And so these two are inverses of each other. My friend Rhiannon wants to see why this is interesting or cool, and I'm going to try to show that to her right now. We take out our graphing calculator. Let us climb the mountain of confusion today. What's that? Get up and do jumping. Yes, yes. As you feel yourself dozing off, again, it's normal. We just got through daylight savings. It's supposed to be an hour later than what it is. You're getting tired. You had lunch. Get up, move around. 3x minus 6. And then I'm going to type in x plus 6 divided by 3. And I'm going to get rid of this one right here. Okay. And I'm going to zoom as a square. And look at my graph here. I have these two graphs. And here's something that's interesting about them as inverses. This one has a y-intercept of 6, negative 6. So its inverse should have an x-intercept of negative 6. See that? Right? Look at this one right here. This function has an x-intercept of 2, so its inverse should have a y-intercept of 2, and it does. And here's what's really cool to kind of check to see your answer graphically if it's correct. If you take this and put in y equals x, you can see that it splits it right down the middle. In fact, if they are inverses, then the one function is reflected over the line y equals x. So instead of reflecting it over the x-axis or the y-axis, it's actually reflected over that line. So graphically, they are reflected over the line y equals x. So you're going to see later, we're going to check that, and it's going to be pretty interesting. Okay. Now, before we get into some concrete examples, I just want to lay one more piece of groundwork. I'm going to give you the function 3, 5, and 4, 5. Okay. If I ask you f of 3, what would you tell me? 5. If I ask you f of 4, what would you tell me? 5. If I ask you f inverse of 5, what would you tell me? Yeah, it's like, which one is it? So therefore, the inverse is not a function. And so this is not one-to-one, okay? Because we have two outputs, or we have one output that corresponds with two inputs. So this is not one-to-one. So in these type of problems, it's important that we state that f is one-to-one to guarantee that we come out with just one value for its inverse. It says that f of 2 is 3, f of 1 is 9, f of negative 3 is 8, and f of 4 is 5. Therefore, what would be f inverse of 8? It would be negative 3. What would be f inverse of 3? Yep, I locate the output of 3. That corresponds with an input of 2. F inverse of 5. And f inverse of 9 is going to be 1. Not too bad, huh? Okay, so those are the first type of problems you should be able to do. We all good with that? Let's move on to a second example. It says, given the function is 3x minus 8, find f inverse of 6. Is 6 an x value or a y value? It's a y value. How would I find the corresponding x value? Plug it in where? To f of x. So 6 is equal to 3x minus 8. 14 is equal to 3x. So I get an x value of 14 thirds. Will give you an output of 6. Good with that? Okay. Let's find inverses. In order to find inverses, I take y is equal to 2x minus 5, and I change it to x equals 2y minus 5. And I have x plus 5 is equal to 2y. So x plus 5 divided by 2 is equal to y. If you'd like to write it as 1 half x plus 5 halves, that's fine. And if instead of writing y, you'd like to write x plus 5 over 2 is equal to f inverse of x, that's fine as well. Just please note that f inverse of x is not 1 over f of x. That is not the case. You're not taking it to a power. We use this -1 piece to indicate that we are, in fact, doing inverses. Okay, the next one, slightly more difficult. We have y is equal to 2 minus x over 3x minus 4. I'm going to rewrite that as x over 1 equals 2 minus y over 3y minus 4. What makes this problem more difficult? I got multiple variables. So what will I do? Cross multiply. You've seen this problem before. Now what? Get all the y's on one side. Good job, Rhiannon. Even though you make hateful comments towards me, I will still give you credit. Now what? Whoa. I factor out the y. And we get 2 plus 4x is equal to y times 3x plus 1. I get y is equal to 2 plus 4x over 3x plus 1. You saw that on chapter 1.5. You also saw it on your final exam. So we prepared you for that, correct? Good. Everybody okay there? Okay, just have a couple more to get through. Here we have a cubic, so we have y is equal to 2 minus 3x cubed. So I need to take x and set it equal to 2 minus 3y cubed. How will we solve this? Anybody? Very good. Subtract 2. Divide by my -3. How do I get rid of the cube? Take the third root or raise it to the 1/3 power. And so we have y is equal to the cubed root of x minus 2 over -3. Yeah, actually, I shouldn't leave the denominator like that, should I? The denominator is not rationalized, is it? Let's just leave it. Okay, so, but I'm curious as to whether or not it's right. So what I'm going to do is I'm going to go into my y equals. I'm going to type in 2 minus 3x to the 3rd power. And then below that, I'm going to type in the cubed root, so that would be number 4 in your math section. X minus 2 divided by -3 parentheses. And as I graph this, it generates the cubic very quickly. The cubed root 1 is the 1 reflected over the line y equals x. It's kind of cool, isn't it? Always does that, divides it right in the middle. And so we can rest assured that that is for sure the inverse, okay? All right, this one is going to cause us a problem, and it's hard for you to maybe anticipate or see why, but let's consider the graph first. What does this graph look like? What's its parent function? Yep, and so it's going to be shifted to the left, 1, and up 4. Good, so back 1 and up 4. So I have that location, so -1, +4. So that's really where it begins. Okay, that's its starting point. So what will be the starting point of its inverse? 4, -1. So its inverse should have a starting point of 4, -1. Agreed? And if I did flip it over the line y equals x, wouldn't you get kind of that kind of a shape? Y'all okay with that? So let's solve. We have x is equal to 4 plus the root of y plus 1. What do I do to both sides? Subtract 4. Very good. X minus 4 is equal to the square root of y plus 1. Then you square it. We're just going to leave it like this, and we'll subtract the 1. Because it's in vertex form, and I could graph that really quick, right? So I get x minus 4 quantity squared minus 1. Now, what shape does that make? A parabola that has a vertex at 4, -1. So I have 4, -1, but look, I have a parabola. So, well, what the heck just happened there? Oh, dang it. You know, the fact is, the fact is that the original function was 1 to 1, but its inverse did not come up 1 to 1. I've got a problem here. I just wanted the red. I came up with the blue. Why? I raised the degree, didn't I? I squared both sides. I came up with a squared. So our new function added on a little bit extra. So all we need to do to finish this off is just give it a little domain restriction. If I just want the red, what should the domain be? Very good, 4 to infinity. Now it works out. Yeah. So our last example, example 4, we will now actually prove that two functions are inverses of each other. And this is the last piece, and this is where I really want Rhiannon to say, oh, wow, that is really cool. So, but I want it to be genuine. I don't want to be forced. So if it doesn't happen, it doesn't happen. So this is my goal, okay? So, Rhiannon, if I have the number 3, what is the additive inverse of 3? Do you know? Do you know what the additive inverse of 3? It is -3, because when I add those together, I get 0. 0 is what we call the identity number under the operation of addition. Suppose I have the number 4/5. What would I multiply that? What is its multiplicative inverse? Not negative, but just positive 5/4, because when I multiply those together, I get 1, because 1 is the multiplicative identity, right? If you multiply anything by 1, you get itself. If you add anything to 0, you get itself, okay? And so the question is, what does that look like for composition? And this is the really cool thing. If you do f of f inverse, so if you take two inverses and compose them together, the output will be x. Yeah, just think about it. If you start with xy, if you do f of x, you'll get y, and then if you do f inverse of y, you'll get x. So you should come out with x. And if you do, but you got to check both ways. So f of f inverse should be x, and f inverse of f should be x. And if we come out with x when we compose these functions together, then we know that they are inverses of each other. So let's end with that for today by doing example number 4. Use the property of inverses to determine if f and g, in fact, are inverses of each other. So I will take f composed of g. And we have done composition yesterday, right? So we have these two new operations that we've learned, inverse of functions and composition of functions. So I'm going to take this and place it right there. And I get 3 times x plus 5 over 3 minus 5. What is the first part that simplifies here? The 3's cancel, and I get x plus 5 minus 5. And what does that give me? I don't even remember. YouTube, they're going nuts. They all want to be math majors now. I'm so proud of you guys. All right, so now you take, if we're going to compose g of f of x, I take f and I plug it in for x over there, and I get 3x minus 5, that quantity, plus 5, and then divide it by 3. And you can see that we get 3x over 3, which is x. So yes, they are inverses of each other. Now, here's what some people will do on the test. I want to make sure that we're clear about this. They can't remember what to do, but they can remember that you're supposed to come out with x. So they will do this, which I will award you 0 points. And their response will be, I already knew what to do. Why do I have to show my work? My response is, you don't have a degree in mathematics. You haven't proven it yet, so you have to show your work. Go get your degree, and then you don't have to show it. Deal? Deal. He talked. All right, okay. Here we go. Let's do it again. Let's see if these are inverses. F of g of x. I take this and I place it right there. It's kind of hard for people to figure out how to write this sometimes. Just make sure you use parentheses. Instead of writing x, I write 1 over x minus 2. That will be in parentheses. And then I have a plus 2. So what simplifies first here? The 2's cancel. I get 1 over x. You just get x, yeah. Then we will do g of f of x. Remember, we got to do both ways because composition is not commutative. You can't just switch them around and have it all work out. So we could end up with something different. And so this time we will take f and we'll plug it in right there. So we have 1 over x plus 2 and then minus 2, which is x plus 2 minus 2, and I get x. Right? As you read C, what's different about C? Yeah, there's a domain piece there where x is greater or equal to 0. Why do you think they say x has to be greater or equal to 0? Because the parabola is not it's not 1-to-1. And because it's not 1-to-1, we have to make it 1-to-1. So we're going to say we don't want to talk about the whole parabola. We just want to talk about that much. Okay? So f of g of x is, take g, plug it right there, 4 times the root of x over 2 quantity squared, which is 4 times x over 4. Sweet. And we have to do it the other way. G of f of x. And take that, plug it in there. Square root of 4x squared over 2. So that one worked out. Oh, thank you. Good job, kiddo. All right. Last example. It's written as C, should be D. What do you notice about these two functions? They are the same. Do you think it's possible that two functions could be the same and yet be inverses of each other? Y equals x is an example. Y equals 1 over x. In fact, there are an infinite number of examples where the inverse is itself. So just because you see that they're the same doesn't mean you can say, well, that's not possible. So let's check to see if it works out. F of g of x. And I get 1 over x cubed quantity cubed. It'll be 1 over x to the 9th, which is x to the 9th. So did that work? So f and g are not inverses. It's sad. You're a terrible smiley face, okay? All right. Okay. What do you want, Jake from State Farm? Huh? Huh? What should we grab here? What do we got? Where do I go? I haven't gone this for a while. What do I grab? Come on. Where is it, you guys? I want like where I can grab different stuff up here. Oh, I see it. I see it. I see it. Oh, I just got stars. I want the smiley face for crying. Oh, this is stupid. Okay. I'll figure it out. All right. So your assignment, it looks lengthy, but it's not. Okay. These problems go pretty quick. We're very happy to have Jill and Elena and Jared back, and Braden and Terry. Though I will say it was a lot quieter yesterday, wasn't it? Yeah. Yeah. There's your assignment, folks. Go to work.